Hello, this is Mr. Huber. In this lesson, we're going to look more closely at factors and zeros of polynomials and how those relate to their graphs as well. First, let's talk about factoring completely. When we want to factor something, first look for a greatest common factor, and then factor what you have remaining if that's possible. So we're going to see a couple of examples of that here, because we want to be able to use factoring to help us find our zeros and then help us with the graphing as well. So in this first example, there is a common factor of an x that I can take out of each of these terms. So as a greatest common factor of x. All three of these factors, all three of these terms have a common factor of x. I can take an x out of x to the third, 7x squared, and 10x. And when I do that, I take the x out of each of those, and the factors that are left over are the x squared minus 7x and plus 10. Now I'm going to look at what I have left over here in parentheses and see if I can factor that any further. And since I can, I need to do that. To factor it completely, this would be x is still one of the factors, and then I have x minus 5 and x minus 2, because negative 5 times negative 2 is 10, and they add up to negative 7. That's the correct factoring. This is factored completely. Okay. If we look at the next example, we can factor a 3y to the third out of both of those terms. We'll be left with a y squared, because if I take y to the third away from this, I have two y's left over, y to the second. And I can factor 3 out of the 3 and the 75. When I do that, my second part of my binomial here is going to be minus 25. So I have 3y to the third, and then in parentheses, y squared minus 25. Y squared minus 25 can't be factored. That's a difference of squares. It's one of our special factoring patterns, if you recall. So I could factor that a little further, and I could have 3y to the third, and then y plus 5, and y minus 5. That would be factored completely. We're going to see how some of these factors and things relate to the polynomials and their graphs here, but first, a little history lesson on retail industry. What was the first item purchased by scanning a UPC barcode? You've seen these codes on things. They scan them over the register, and boom, the price pops up. Okay, so what was the first item that was ever scanned using that UPC barcode? You can see here a pack of gum. That juicy fruit gum, back in 1974, was the first item scanned with a UPC barcode. Now, things are scanned for all types of stuff, not even just items we buy at the store. Pretty commonplace. All right. Let's talk about how we can use factoring and solutions and zeros. Okay? The solution of an equation is sometimes called the zero of the equation, because it's the number that if I plug back in will make the equation equal to 0. We can see some of that in the example we have here and written out. I'm not going to read the whole thing to you, but we factor this equation, and we would have these two factors both set equal to 0, would give us solutions of negative 3 and negative 2. You recall we can set x plus 3 equals 0, x plus 2 equals 0. So we've factored and solved some equations before. And now we can check. Let's try the negative 2. Okay, if I plug negative 2 back into this original equation right here, I get negative 2 squared plus 5 times negative 2 plus 6. Do the calculations, and it becomes 0. When I plug a negative 2 into this equation, it equals 0. So these solutions, okay, right, these are the solutions of the equation, negative 3 and negative 2. Those are sometimes called the zeros of the equation, because they're the values of x that if I plug into the equation will make it equal to 0. So be aware of that. We've seen that too on our graphing, where we can find zeros on the graph. Those are the points where we have a y value of 0. The x coordinates to give us a y value of 0. Right? So let's see what that looks like with some graphing. If this graph is factored, this equation, is factored, x plus 3 and x minus 5, we can use those to find the graph, the zeros of it to start with. This would have zeros of negative 3 and positive 5. That means our graph is going to go through the points on the y-axis, the x-axis of negative 3 and 5, where we have a y value of 0. These are the x-coordinates that give a y value of 0, right? And if I want to get a more exact graph, I know it goes through those 2 points, okay? One thing I could do, I can see that this has a positive a value here, right? There's nothing written there. That means it'd be a positive 1. So it's going to be opening up on both ends, because it's even. X times x would be an x squared. So it's going to be like a parabola that opens up. Okay? If I want to get another point down here where the vertex might be, one of the things I can do is I can just find what's between -3 and 5. So between -3 and 5 would be 1. So I can plug in an x value of 1 and find out what happens in the middle between these two zeros. So let's do that. We're going to plug in an x value of 1. When I do that, I'm going to get 1 plus 3, and then 1 minus 5. So that'd be 4 and -4. That'd be -16. So we'd have a y value of -16. So it would be down off of the graph for this, right? If I was going to graph that, I have to scroll down here, and I might have a point then for this that's at 1 comma -16 down here, and I could draw on a graph then that goes through those zeros, okay, and has that vertex, that point there that I just figured out of 1 comma -16. So you can pick a point in between your two zeros and see what happens in between them, and you get what happens for the curve. This parabola, you might say, oh, we could multiply it out and get it in standard form and, you know, find other ways to get the vertex. That's true. But we're going to see in an example like we have next, it's not a parabola, it might be something we're a little less familiar with. So we want to use that method of finding some other points between the zeros. So for this particular example, we're going to take each of these factors and set them equal to 0, right? The reason I'm writing them all out equals 0 so we don't forget to plug in x equals 0, right? X is one of the factors. You take each factor and set them equal to 0, even this x. It doesn't matter if it's not in parentheses or plus or minus another number. X equals 0, x plus 5 equals 0, x plus 2 equals 0. That means I'm going to have my zeros of x would equal 0, x would equal -5, and x would equal -2. So I can plug those points in on my graph at -5, -2, and 0. Those are some points then that would be on my graph. Okay. Now I want to figure out what happens in between them. So I need to figure out something in between here and in between here. So let's do this one, -1. -1's right in the middle between 0 and -2. So I can plug in -1 into this equation. So when I do x equals -1, I wrote a 7 there, let's change that. Okay, so x equals -1. We're going to get -1, -1 plus 5, -1 plus 2. It's -1 times 4 times 1. That's going to equal -4. So I have the point -1 comma -4. -1 comma -4. I can plug that point right there. Now in between here, -2 and -5 would be -3.5, right? So I could put that in exactly at -3.5. Okay, that's fine. So we're going to do -3.5. And we get -3.5 times -3.5 plus 5 times -3.5 plus 2. Okay, so when I go to put that in, I can just put that right in the calculator. I can do -3.5, and then you could type it in just like you see there. In that first parenthesis would be 1.5 if you want to do the calculation there. You don't have to. You can just type it in with the parentheses and everything you see there, and then in the second parenthesis would be -1.5. Okay, or you could just type all of this in. If you're comfortable putting it on your calculator correctly, make sure you got the right negatives and the right numbers in places. But if you want to do this, it would be 1.5, and this would be -1.5, and you calculate that all, and it comes out to 7.875, okay? So the y would equal 7.875. So just a little below 8. So when we go to graph that, it would be just a little below 8, maybe right in there, okay? And then I can draw in my graph, okay? I could look at what's going to happen when I have x times x times x. This would be something with x to the third, and it'd have a positive leading coefficient. So it's an odd degree and a positive leading coefficient. It means it's going to go down on the left and up on the right, which you can see kind of what happened. I'd go from this point, up through this point, down through here, and then I'm going to go up to the right, and I'll be going down to the left. So you can draw a sketch of that curve in there. So I'm going to go through here, turning point there, down through that other 0, turning point, up through there, and then up to the right. And that would be a sketch a little bit of the graph where I've got key points, the zeros, -5, -2, and 0, right? I got those from up here. Get your zeros, and then you can figure out what happens in between the zeros, okay? And if something doesn't look right, if you had a negative 7.875 and it was down here somewhere, that might not look right, because then what are you going to do? Go up like this, and then to here, and then where am I going to turn again? And it should be going down to the left and up to the right. So we want to use those things we know should happen about our graph, along with those intercepts, okay, the zeros along this axis, okay, where we have a y value of 0, the x values give us a y value of 0. And you can get a general idea and a good idea of what the graph's going to look like. Let's talk about how we can write an actual equation, okay? So if we know the zeros of a polynomial are -2, 3, and 6, we can use that to write the actual equation, okay? Because we're going to know that if one of the zeros is -2, that means one of the factors is x plus 2. And if one of the zeros is 3, that means one of the factors is x minus 3. And the other factor would be x minus 6. And now we can multiply all this out. So we're going to start by taking these first two binomials here and foiling them. So I'm going to FOIL these, and I'm going to do x times x, which is x squared. X times -3 is -3x. 2 times x is plus 2x. And 2 times -3 is -6. And that's going to give me x squared minus 1x minus 6. And then I'm going to multiply that by, now I'm going to bring this other factor down that I didn't multiply out yet, x minus 6, that just came down here. And now I'm going to multiply these together. That's going to require distributing the x squared into the parentheses. That's x to the third minus 6x squared. Then I'm going to multiply the negative x into the parentheses. That's negative x squared and plus 6x, right? When I multiply negative x times x, I get negative x squared. When I multiply negative x times -6, I get a positive 6x. And now I'm going to need to multiply the -6 into the parentheses. Negative 6x. And then -6 times -6 is a plus 36. And I've got some like terms that I can combine here. So when we look at this and we talk about what are some like terms, okay, first the x to the third isn't going to change. I don't have anything that can go with the x to the third. So I'm going to bring my final answer up here. Okay? So I'm going to have x to the third. Then if I look at my next terms here, I'm going to have two terms with an x squared. I can combine those, -6 and -1. So that's going to be a -7x squared. Okay. And then if I look here, I've got two more like terms, 6x and -6x. Those are going to cancel out. That's 0x, so I don't have to write that up there. And then I've got the plus 36. So then I'd go plus 36. And that would be my final answer. That would be an equation written using those as zeros. So again, the zeros tell us what the factors are. We use these zeros right here to write out our factors. And then we can multiply all the factors together to get our equation. Okay. So let's try another one. Again, you should be trying these. See if you can write this out and get the correct final polynomial written. Okay. So hopefully you have tried this one out, and we can see how it goes for you here if we write our factors as x plus 4, x minus 1, and x minus 1 again. Okay? And I'm going to show you it doesn't matter which order we multiply them in. I can multiply these two together first. I can multiply these two together first. I can multiply the first and third. It doesn't matter what order. I'm going to multiply the second two together first. It doesn't really matter. I'm just going to do something a little different so you can see there's different methods for how we could do this. So now if I multiply together these second two terms, right, I'm going to FOIL them. You should be familiar with foiling. If you're having trouble with that, let's do some extra practice on that. We're going to have x squared minus x, and then plus 1, because it's -1 times -1. And then I'm going to have my other factor still as x plus 4. Okay. Now when I FOIL this, I'm going to multiply x times all three of these terms. Sorry, I needed to simplify that second one first. I did not do that yet, so let me rewrite that out. So it's going to be x plus 4. And then my second factor is going to be x squared minus 2x plus 1. Okay? So x squared minus 2x plus 1, because I combined my two middle terms here. -x and -x combined to -2x. Now I'm going to distribute, jumping the gun there a little bit, to all three of these terms. I said three terms. So it's going to be x times x squared is x to the third. X times -2x is -2x squared. X times 1 is plus x. Okay, that's distributing this x times x squared times -2x times 1. And now I'm going to distribute the 4 into the parentheses as well. So I'm going to have 4 times x squared is plus 4x squared. 4 times -2 is -8x. and then 4 times 1 is 4. And now I want to look for any like terms to combine. I have the x to the third by itself. I also see I've got a minus 2x squared and a plus 4x squared. So I combine those. They're like terms because they have the same variable, the same power, x squared and x squared. So negative 2 plus 4 would be a positive 2x squared. So plus 2x squared. Then I've got the x and minus 8x, which is negative 7x, and then the plus 4. So that would be my polynomial written. They would have these as my zeros. Okay, those zeros give me these 3 factors, which I can multiply factors together and get my final polynomial answer. Okay, so you can see how the factors and the zeros tie together, what they mean in terms of the graph and the intercepts that we can use, and then how we can use those zeros to get our factors and write equations. So we want to be able to be aware of how these all things tie together. The zeros and the factors and the solutions and the intercepts are all giving us that same information. So be aware of how they're related to one another and how we can use them depending on what information we're given and what we're trying to get out of it.